When starting to learn Docker, one of the questions people have immediately is, what is the difference between a container and a virtual machine? Because Docker is a virtualization tool, just like virtual machine. So why is there such a hype around Docker, and why did it become so widely used, even though we've had virtual machines available for a long time already? So in this video, we're going to understand the differences between containers and virtual machines and how they both work on top of an operating system. In order to understand how Docker works on the operating system level, let's first look at how operating system is made up. So operating systems have two layers: operating system kernel and the applications layer. So as you see in this diagram, the kernel is the part that communicates with the hardware components like CPU and memory, etc. And the applications run on the kernel layer. So they are based on the kernel. So for example, you all know Linux operating system, and there are lots of distributions of Linux out there. There's Ubuntu and Debian, and there's Linux Mint, etc. There are hundreds of distributions. They all look different, so the graphical user interface is different, the file system is maybe different. So a lot of applications that you use are different because even though they use the same Linux kernel, they use different, or they implement different applications on top of that kernel. So as you know, Docker and virtual machine, they're both virtualization tools. So the question here is, what parts of the operating system they virtualize? So Docker virtualizes the applications layer. So when you download a Docker image, it actually contains the applications layer of the operating system and some other applications installed on top of it. And it uses the kernel of the host because it doesn't have its own kernel. The virtual box, or the virtual machine, on the other hand, has the applications layer and its own kernel. So it virtualizes the complete operating system, which means that when you download a virtual machine image on your host, it doesn't use your host kernel, it boots up its own. So what does this difference between Docker and virtual machine actually mean? So first of all, the size of Docker images are much smaller because they just have to implement one layer. So Docker images are usually a couple of megabytes. Virtual machine images, on the other hand, can be a couple of gigabytes large. A second one is the speed. So you can run and start Docker containers much faster than the VMs because every time you start them, they have to boot the operating system kernel and the applications on top of it. The third difference is compatibility. So you can run a virtual machine image of any operating system on any other operating system host, but you can't do that with Docker. So what is the problem here? Let's say you have a Windows operating system with Windows kernel and its application layer, and you want to run a Linux-based Docker image directly on that Windows host. The problem here is that Linux-based Docker image cannot use the Windows kernel. It would need a Linux kernel to run, because you can't run a Linux application layer on a Windows kernel. So that's kind of an issue with Docker. However, when you're developing on Windows or macOS, you want to run various services, because most containers for the popular services are actually Linux-based. Also interesting to note that Docker was originally written and built for Linux. But later, Docker actually made an update and developed what's called Docker Desktop for Windows and Mac, which made it possible to run Linux-based containers on Windows and Mac computers as well. So the way it works is that Docker Desktop uses a hypervisor layer with a lightweight Linux distribution on top of it to provide the needed Linux kernel, and this way make running Linux-based containers possible on Windows and Mac operating systems. So this means for local development, as an engineer, you would install Docker Desktop on your Windows or Mac OS computer to run Linux-based images, which, as I mentioned, most of the popular services, databases, etc., are mostly Linux-based, so you would need that.